Hello there boys, welcome back to this video tutorial. Now today we are going to be looking at your feedback on current electricity. So on current electricity that you did. So make sure that you do have the title down and the date written down before we get started. Okay, so here are a few rules, expectations that you guys need to follow. So you need to power open your work. Okay, you need to show all working out. I need to see this. Okay, any question that you got wrong partly need to be done. Okay, so pop up in any wrong questions. It could be partly wrong or it could be fully wrong. Okay, so here we go. Now let's get started. Let me just change my color here. Okay, now the first question is we have the power supplied. Okay, we've got P, right, and we need to work out the current in this case. Now there's one information that we do know, and the information we do know is the voltage is 230 volts. Now the equation you are going to need, so first of all I need to see the following equation. So I need to see P is equal to VI. So this is the equation you're going to need. You rearrange it, you get I is equal to P over V, and then you get 2. Now this here is in kilo, so we need to turn this into, so 2.6 kilo is this much. So I need to see that you've converted it and divided it, and then we get an answer of roughly 11 amps. Okay, you can leave it in decimal points if you do want to do that, it's up to you. I'll write 11 here. Okay, so this is your marks. Now if you don't get, okay, these are your, will become your marks pretty much. The answers working out, and here we go. Now pretty much every one of you got this right. Now let's take a look at this one here. We've got two figures, 21 and 22, a different voltage of course throughout the wire. Now this one here is going up to 14 and then goes down to minus 14. Alright, this one, 22, it is at 10 and it never hits minus 10, so it stays at 10 consistently in this case. Now explain which of the voltage in these two figures cause an AC current. Now an AC current, for it to be an AC current, what do we need to have? It needs to be changing signs. It needs to be changing direction from positive to negative. Okay, so for you to get your mark, so first of all it is figure 21. Now why, you need to say why is it figure 21? Okay, because the voltage is changes sign, so positive to negative. Okay, so this means that the current will be AC, means that the current will be AC, in this case, so AC current. Now, however, this only gives you 1 mark. It's 2 marks. It says here, explain which of the voltage in figure 21 and in figure 22. So we need to explain why figure 22 is not AC. Now, figure 22, in this case, okay, so here, the voltage, okay, is always positive. So you need to say that this here is always positive, so direct, so DC direct current. This here you begin getting a mark. So most of you forgot to talk about 22. You've only talked about 21. Okay, and this is 2 marks, as you can see. So for 2 marks, you need to talk about 21 as well as 22. So 22 is not AC, because voltage is always positive in this case, and you need to talk about the other one. That's why we are going to be picking a mark. Right, now let's take a look at the 6-mark question. Now this question here, explain with an aid of a diagram. So I need to see a diagram there. How the resistance of a lamp changes with potential difference. The potential difference is the same thing as voltage across a lamp. Now this practical is, we've done this practical. Okay, if you remember, when we did the practical, we did 3 practical at once. We look at the diode, we look at the lamp, we look at the resistor. So here we're talking about the resistor. So first of all, we need to have a circuit diagram. Again, in that circuit diagram, we've got the battery. Okay, Ideally, you're going to be using a ruler. Okay. Alright, so you're going to have your battery or your cell, your power pack. Okay, so here I have my circuit diagram. So as you can see, we got our battery here. We have our ammeter, as you can see, in series. We have our bulb or lamp, and then we have our voltmeter here. Now the voltmeter needs to be connected in parallel. Here we go. Now, what are the things that we need to do? So we are going to be looking at resistance finally. So resistance, if you remember the equation, so V is equal to IR. We're looking for resistance. So resistance is V over I. So what do we need? So here, ask yourself, what are the steps you need to take in order to get R? So first of all, step number 1, bullet points. Okay. Set up the equipment as shown above. Okay, that's it. So just by looking at it, we say set it up. So once we set it up, let's take a look. What else can we say in this case? Okay, I need to label this. Okay, here we go. Now, we need to say we need to, so here, let's say we need to measure the voltage using, we need to say you measuring the voltage, yes, but we want using voltmeter, because we did this practical. So you need to show method. So you need to say what you're measuring and how you're measuring it. Okay, so measure this using the voltmeter, and then next we need to measure the current. Measure the current with what? Using, how we're going to measure it? Using ammeter. Okay, using the ammeter. So we need to see those things. Right now, so what's happening is we want to know how the resistance changes with changing of voltmeter with changes with the potential difference. Sorry. Now, if you remember when we did the practical, when we are changing the voltage, we are changing the voltage from the dial of the battery, okay, or the power packs. In this case, what we are doing is we are increasing the voltage. Okay, so we need to vary the voltage. Now, how are we going to be varying the voltage? So if you're using power pack, you change the power pack. In this case, vary the voltage using different or / higher voltage battery. Now you see that here I'm not saying by changing the dial on the voltage or by increasing the voltage. So vary the voltage by changing the dial on the power pack, because in my diagram I'm dealing with the battery. If I want to talk about vary the voltage using the dial on the power pack, then in my diagram I need to have the power pack there as well. Okay, otherwise it is not consistent. Okay, so you cannot put battery and then in your method you talk about the power pack. These two are different things. You need to remain consistent when you do talk about them. Here I talk about the battery. Now how can I change the voltage of the battery? So here I need to change the voltage by replacing the battery and add a higher voltage battery. Okay, but here we go. Okay, now what do? Is we have repeated the experiments for different values of voltage. Okay, and then recorded our answer. That's what we've done. Okay, that's what we've done. And then what have we done? We took an average. Remember, we did it 3 times, and then we did an average of the current and the voltage, and took an average. Okay, that's done. And finally, let me just put a bullet point here. Finally, okay, we have calculated resistance. So R is equal to IV. Okay, this is how you're going to be getting your mark. Now you need to say this here, repeat, and then take an average. So we are comparing our answer as well. Repeat and compare and so on. So here, how you are going to be getting your 6 marker. You start with the diagram, you start with the equation, ask yourself what you are looking for, and then how do you need to get that? What are you using to get that? Okay, see how easily you can easily score a 6 mark question there. Alright, now question 4. Let's take a look what we have so far. We have the voltage. Now the question is, which of these is a unit for voltage? Now, if you look carefully, we are talking about joules here. There's another equation that has voltage in it. So the equation we're going to be using is E is equal to VQ. Now, let me rearrange for V. So V is equal to E over Q. Now, what's the unit for E? It's joules, yeah? So units for E is joules. Okay, so unit for E, let me just circle it so you know. So unit for energy is joules. Now what I'm doing, I'm dividing it by Q. What's the unit for Q? Q is charge. What's the unit for Q? Q is coulombs. So therefore it's going to be joules per coulomb. So therefore the answer will be C. This one here. Again, we are using the equation. And this brings us to the next question, as you can see here. Now, what we know is we know the current, so I, we know the charge, work out time. Which equation has these 3 together? So the equation we have is I, current is the rate of flow of charge. Here we go. Rearrange this, we're looking for time. So rearrange this, get time. So now time is here, so therefore it's going to be Q over I. Now let's substitute it here. Charge is 42. However, current is 200 milliamps. So this is 200 milliamps. So this is 200 times 10 to the power minus 3, same as this divided by 1000. So this will give us 0.2 amps. Okay, so you need to know your conversion, boys. Okay, you are in your 10, so you need to know that. So it's going to be 42 divided by 0.2, and this will give you 1/10 seconds. The answer needs to be in minutes. So seconds, turn this into minutes. We need to do divided by 60 in this case, because there's 60. How many seconds are there in 1 minute? 60 minutes. Sorry, how many seconds are there in 1 minute? 60 seconds. So therefore 0.5. In this case the answer is 0.5. If you do this in your calculator, you get an answer exactly 3.5. If you put 3, that's wrong. If you put 3, that's wrong. Okay, 3.5, because that's what the calculator gives you an exact number there. There's no recurring or anything. Right? Let's move on. Now we have this here, and we have charge. We've got voltage, so V. We've got charge, Q. We are looking for E. Which equation has these 3 together? E is equal to VQ, V6, and here we go, multiply them together, we get an answer of, here we go, joules. And this is your 2 marks. As you can see how easily it is to get these marks here. Let's keep going. That's a good question. So here we have the power pack. connected to these one here. So here, this one is connected to the next one, connected to the next one, and so on. So therefore, these guys, they are connected in series, one after the other. Now, potential difference in voltage. What happened to voltage in series? They are shared. So now, each of these lamps, they are identical. They are going to be shared equally. There's 1, 2, 3, 4, 5, 6, 7, 8. Okay? So therefore, how much do we get? So therefore, it's going to be 12. The total divided by 8. This will give me 1.5 volts. So each of these here will have 1.5. So this guy will have 1.5, 1.5, 1.5, 1.5, 1.5, 1.5, 1.5, 1.5. So you get it, okay? 1.5. Now let's move to this one. Work out the power is this one. Work out the resistance. Okay. Now there are a few ways you can do this. There are a few ways. Let me go through the long way here. Now the long way is, let's take a look. Which equation has R in it? So we know that the equation that has R is V is equal to IR. Okay. Now we know V previously. We already worked this out. However, we have no idea about current. Can we work out current? But we don't know this one. Now let's go back. What equation has power? Power is equal to IV. Now we know power, we know V. We can easily work out I. So I is equal to P over V. So 0. This divided by 1.5. As you can see here, this will give me my current, and my current will be 0.5 amps. And now I take this number, I plug this into this value. So I rearrange this equation first to work out R, V over I. How much is V? Each lamp it has 1.5 divided by the current 0.5, and this will give me an answer of 3 ohms. This is my answer there for 4 marks. This is the long way. Now let me show you the short way. The short way, so this is the long, let me just put the long way here. The short way is you need to remember one equation. The equation you need to remember is P is equal to V squared over R. That's the short way. You rearrange this for R. You have V squared over P. So V, you know, is 1.5 squared divided by 0.75, and you should get an answer of 3 as well. Okay, an answer of 3. Okay, now the long method, you only need to memorize the basic equation. So this here is the basic equation, this here is the basic equation. You only need to memorize these two, and then you can work your way out using problem solving. The short way, you just need to memorize one equation, and it's just straightforward. As you can see, if you memorize the short way, memorize this equation, look how short it is compared to the long one. Okay. Now, question 6. We have 2 resistor. So there are 2 ohms resistor. So we got a resistor here, 2 ohms. We got another one. It is inside this cardboard. We can't see it. Okay, we don't know how it's connected. So what we do know is we know that we are giving it a voltage of 6 volts. 6 volts across this, and the current in the wire is this one here. Now we want to know how they are arranged. So it could be either in parallel or in series. We have no idea because we can't see. However, we need to use our maths skills and what we know of electricity to work this out. Now let's take a look. We know there are 2 possibilities. Either they're connected in series, back to back, or they're connected in parallel. Okay, there we go. Now let's take a look. Now I have the voltage, I have the current. V is equal to IR. Voltage, current. So I can work out the resistance. Okay, let me work out the resistance. Resistance is equal to V over I. So 6 divided by 1.2, and this will give me 5 ohms. So it's telling me here that the resistance inside this is 5 ohms. However, each of them is worth 10. So how is it possible? How is it possible? Now let's take a look at this situation here. If they are connected in series, so this is series, it means that this will have 10, this will have 10. Now since they are connected back to back, the resistance, the total resistance, so total R would be 20 ohms. Okay, and here they are in parallel. So parallel here, we have no idea how to work this out. But we do know that if they are in series, then it will give me 20 ohms. But here, I'm getting 5 ohms inside of it. So this tells me that it cannot be series. It cannot be series. The only possible answer will be in parallel. So we need to find a way to work this out. Okay? Now, if they were in series, the resistance would be 20 ohms, but what will happen is we get 5 ohms, so it must be parallel. Okay, that's one way of looking at it. The second way of looking at it is the current. Okay, is the current. So you can argue that you can work out the current individually in this case. So for example, V is equal to IR, V is equal to IR, V is equal to IR. Now, if it's in parallel, know that the current will be split. Sorry, the current will be split, but the voltage will stay the same. So it'll be 6 over 10, and this gives 0.6. Okay, so so one resistor will have 0.6, and the other resistor has 0.6. So split up. Okay, but if this were in in series, if this were in series, then the current should be the same in series, so it should be 1.2. Okay, but however, when we calculated it, we do not get 1.2, we get 0.6, so therefore it is in parallel. As you can see, there are two ways of doing it. Whichever is easier, you stick with this here. Okay, let me just draw a line here, so you can either do this here, or you can either do this to get your 3 marks. Now, question 7 is straightforward. It is this one here. If you got this wrong, then you need to pretty much do loads of revision. Okay, so this is just the thermistor. There's no room for error there. This one here is straightforward again. If you're losing mark here, I have no idea what's happening. Okay, so we need to make sure that you guys are nailing these things. Okay, so you need to be working definitely on your independent learning there. So what we are doing is we need to add a voltmeter across R. How do we add a voltmeter? A voltmeter is always connected in parallel. You use a ruler, make sure that the line is straight. This is done. 1. Next, what we need to do, add another resistor in parallel to R. So this is R, add another resistor in parallel. So here we go. Another resistor in parallel. Done. 1 mark for voltmeter in parallel, 1 mark for another resistor in parallel. Okay? Now, measurements. What measurements should we take to work out the resistance? V is equal to IR. If we need to work out the resistance, we need V over R. So measurements we need to be taken would be, okay, we need voltage, need current. Here we go, that's it. That's all we need to say. We need the voltage and we need the current in this case. Okay? This is 2 marks there. If you're losing this, again, you need to be checking yourself. Alright, graph. You see the resistance of a single resistor. Here we have the number of resistors. Here we have the entire resistance. Let's take a look what's happening. We can see that the dot R is going down, down, down. Single resistor, single mean 1. So that's 1, 2, 3. So 1 is here, so I go all the way up. Here, go across, I got 1. So the answer is 1. There's no room for error. Here we go. Now, comment on the relationship between the y-axis and the x-axis. Now I can see that the line is going down. Relationship. This is clearly, okay, what relationship this? If you remember, there's 3 marks. Normally you get 2 marks for saying relationship. What is this relationship? So it's clearly it's going down. Okay, so what relationship? We've done this loads of time. Okay, so relationship, they are inversely proportional. Here you go. This will give you 2 marks, 2 ticks there. Now we need, so since we see there's 3 marks, we need to use the information given to us to support our answer. So what happened is we can say that when the overall resistance decreases, okay, so what happened when it decreases? So as the resistance decreases, okay, what's going on to the number of resistors? The number of resistors increase. That's it. So here we are using the graph telling us what's happening. Now, for those of you who did not put inversely proportional, then you need to get your mark, you need to talk about data, use data. Okay, if you didn't, so let me see, if in, let me just write it down here so you know, for those of you who did not mention, so if you did not mention inversely proportional, okay, and talk about data. So just pick 2 data, for example. Okay, so for example, pick 2 data. So you say when the number of resistors is 1, then the overall resistance is 1, and then when the number of resistors goes to 6, then the overall resistance drop down to probably 0. How much is this? So this is 0.1, could be 0.18 there. So you can clearly see that it's going down. Okay, and this is going to be getting your mark from. Use data and this and this. Alright. Okay, so make sure that you pop up on your work, and when done, move to feedback.